Here we have a square with the side A, and inside the square there are 4 quarter circles. So here's one, here's another one, here's the third one, here's the fourth one. And we asked to find this red area, which is a result of intersection of those circles. Now let's look at our square. We have this red area inside of the square, we have 4 green areas, and we have 4 yellow areas. So essentially, to find the red area, we need to find the area of the square and subtract 4 green areas and 4 yellow areas. So all we need to do is to find those green and yellow areas. Let's start with the green area. So how can we find this green area? Well, one thing to notice that we can create an equilateral triangle here. Why is it an equilateral triangle? And that's because the left side is the radius for this circle. The right side is the radius for this circle. And the bottom side is the radius for both of them. And all these circles has the radius equals to r, same as the side of this square. In addition to this equilateral triangle, we can also find 2 gray sectors right here, one here and one here. To calculate this green area, we need to calculate area of the square and subtract area of this triangle and those 2 gray sectors. The angles in equilateral triangles are 60 degrees, so the angle right here is 60 degrees. Angle of the square is 90 degrees. It means that this sector has 30 degrees. So all we need to do now is to calculate the area of the triangle and area of the sectors. Let's start with the triangle. If you know how to calculate the area of equilateral triangle, that's good for you, but here we're going to review it very quickly. So if I have a triangle ABC, which is equilateral with the side of A, what are we going to do? We're going to drop an altitude BD. And since this is an equilateral triangle, it's isosceles triangle, so this altitude is also going to be side AC bisector. So AD is going to be half of AC. So it's A over 2. And now we can look at triangle ABD, which is a right triangle. We know 2 sides of the triangle. We can use Pythagorean theorem to find the third side. And finally, now we can calculate the area of this triangle as half the height times the base, which is AC. And we're going to get this formula. And now we want to calculate the area of the 30-degree sector. That area will be equal to the area of whole circle, pi a squared, times 30 degrees divided by 360 degrees. So we get pi a squared over 12. And the green area in this case is going to be the area of the square minus area of the triangle and minus 2 gray areas of 30-degree sectors. When we plug everything in, we're going to get a formula for the green area. Next thing is to calculate the yellow area. To understand how to do it, notice that this blue thing is a quarter of a circle with the radius A. So what we find here that this whole square is this blue quarter circle plus this green area plus this yellow area and plus this green area. So in other words, we can write that 2 green areas plus yellow area is the area of the square minus a quarter of the circle. And since we know what green area is, we can calculate the yellow area over here. And we're pretty much done here. Now we can say that the red area equals to the area of the square minus 4 green areas and 4 yellow areas. That's what we have here. Since we know green and yellow area, we can plug them in here and we can get our final answer.